Okay, in this video I'm going to look at how to solve equations involving absolute value. And it's basically involving the definition. That's all there is to it. So let's look at the definition. The absolute value of x, I have x surrounded by two bars, so that's the absolute value symbol. Absolute value of x is equal to x if x is greater than or equal to 0. Okay. If x is non-negative, then the absolute value of x is x. However, second part of the definition, if x is negative or less than 0, then the absolute value of x is minus x. So in other words, the definition is telling you that when you compute the absolute value of any quantity, say a number or an expression, the absolute value will always be either positive or 0. Okay? It's never going to be a negative number. So the absolute value of 2, for example, is going to be 2 because 2 is positive. The absolute value of a negative 2, okay, in this case it's negative, so you take the opposite of that. Of course, the opposite of a negative is a positive, so this comes out to a positive 2. The absolute value of 0 is 0. Okay? So that's what the definition is telling you. When you compute the absolute value of any quantity, it's always going to be a non-negative number. Okay? So that means either a positive number or the value of 0. So we apply that to solving equations. So we're going to look at equations that have at least one absolute value. And the most simplest you can have is the one where you have just one and it's isolated. Okay? So if I look at, say, the absolute value of x is equal to 7. Solve each of the following equations. The first one is the absolute value of x is equal to 7. So we know that the absolute value of 7 is 7. We know that the absolute value of negative 7 is also 7. Okay, so this would tell me then that x has to equal either to a 7 or a negative 7. That's by the definition. Now, keep in mind, if I make this, say I make the equation absolute value of x is equal to a negative 7, then this would have no solution. Solutions that would be empty, because we just said the absolute value of any quantity is always a positive number or 0. Well, negative 7 is not a positive number, it is not 0. Okay, that's all there is to it if you have just one absolute value and it's isolated. Now, if the expression is written in this format, say you have absolute value of x minus 3 is equal to 8, then rewrite it so it looks like this one here. Okay, so you want to make it as simple as you can. So always want to isolate the absolute value term if you can. So in this case, this would be absolute value of x, then adding 3 to both sides will give me 11. So again, based on the definition, if x is positive, then it's x. If x is negative, then it's the opposite of that. So this would tell me then that x has to be either a positive 11 or negative 11. Okay. Absolute value of 11 is 11. Absolute value of negative 11 is also 11. Okay, so you can easily check that. Let's look at the next one. Okay, again, we have one absolute value and it's isolated. So in the same way, because I have x minus 3 in between the absolute value bars, then the only way that this can be equal to 7 is if what I have inside is either a 7 or a negative 7. Okay, so you simply write this and say, okay, x minus 3 then, okay, now I'm removing the absolute values in order to solve it. X minus 3 then has to be either 7 or x minus 3 has to be negative 7. Okay, you can easily see that because the absolute value of 7 is 7, the absolute value of negative 7 is also 7. Okay, so these two equations have to be true. Solve each of these for x. The first one, we add 3 to both sides, and we get 10. Again, the next one, we add 3 to both sides, and we get x is equal to negative 4. Okay, so the solution to the equation, or the solutions in this case, are 10 and negative 4. And you can easily check it. Put a 10 where the x is. 10 minus 3 is 7. Absolute value of 7 is 7. Checks. Put a negative 4. Negative 4 and minus 3 is negative 7. Absolute value of negative 7 is 7. Checks. Okay, clear this. Okay, and the next one in the same way. Work it the same way. Because of definition, that expression in the absolute value has to equal to 2 or negative 2. So let's make this equal to 2, and then 2x minus 5 would be equal to negative 2. Okay, so again, we're saying then if the absolute if 2x minus 5 is positive, then the absolute value of 2x minus 5 has to be 2x minus 5, which is right here. If 2x minus 5 is negative, then by definition we take the negative of that, so I would stick my negative out here. Okay, but that's the same thing as putting it over here. Okay, so it's more convenient just to do it this way. Then I went ahead and go ahead and solve each equation individually. Add 5 to both sides. Now this will give me 7 divided by 2. X is equal to 7 halves. Okay, over here add 5 to both sides. We get 2x. 5 and negative 2 is 3. Divide by 2 here. We get x is equal to 3 halves. So 7 halves and 3 halves is the solution. And you can easily check. Put a 7 halves over here where the x is. The 2's cancel out. I get 7 minus 5 is 2. The absolute value of 2 is 2. Okay. And now put a 3 halves where the x is right here. 3 halves times 2 gives me 3. 3 minus 5 is negative 2, but the absolute value of negative 2 is 2. So it checks. Okay. So you have my two solutions. X is equal to 7 halves or x is equal to 3 halves. Okay, so if I either write it that way, you can write it in a solution set and say, okay, my two solutions are 7 halves and 3 halves. Okay, cancel this. Now the next one has two absolute values, but they're isolated on the left and on the right side. Okay, so we can do this. We can say, okay, let's there's different possibilities. So it could turn out that 2x plus 1 is greater than or equal to 0, or it could be less than 0. It could be that x minus 6 is greater than or equal to 0. It could be less than 0. Okay. So let's assume to start off with that they're both positive. 2x plus 1 and x minus 6 are both, well, greater than or equal to 0. So in that case, I can say that 2x plus 1 then would equal to x minus 6. Okay, because they're both greater than or equal to 0, and the absolute value would give me just the expression in the between the absolute value bars. Okay. Now let's assume that one of them, either 2x plus 1 or the x minus 6, is negative, and the other one is positive. Okay. So what is that going to give me? Okay, so let's assume that the 2x plus 1 is greater than or equal to 0, then the absolute value would be this. And let's assume that the x minus 6 is negative, then the absolute value of that would be the opposite of this. Okay, so in other words, this is a scenario where they're both positive. Okay, so I get this equation. This is the scenario where one of them is negative, okay, and the other one is positive. And notice that if I reverse this and assume that the 2x plus 1 is negative and the x minus 6 is positive, all that happens is the negative would be over here on the left side, and over here I just have the parentheses. But it's still going to be the same expression. Okay, so if I multiply both sides by negative, it puts it over here. Okay. Now, let's suppose that they're both negative. 2x plus 1 and x minus 6 are both negative. Okay, then the absolute value on the left side would be the opposite of what I have there, 2x plus 1. Equal to, and the same thing on the other side, the opposite. Of the x minus 6. Okay, but notice a negative here, those cancel out. So it just gives me the same thing right here. Okay, so instead of going through all the different scenarios, this is what you can do, a little shortcut. If you have two absolute values and they're isolated, one on the left side and one on the right side, then just remove the absolute values, and I get this first equation, solve it, and then remove the absolute values and multiply either the right or the left side by a negative. One or the other, doesn't matter. Okay, so let's just solve this equation. Subtracting x from both sides, we get x. Subtracting 1 from both sides, I get a negative 7. So one solution is x equal to negative 7. Okay, on this one over here, let's just go ahead and multiply through the negative. So this will be minus x plus 6. Okay, now let's add an x to both sides here. So that'll give me a 3x over here. And then at the same time, I'm going to subtract 1 from both sides, isolate the x. That'll give me a 5 over here. So I get x is equal to 5/3. Okay. So again, just to summarize the procedure, when you have two absolute values and they're isolated, the shortcut is simply remove the absolute values and then set the quantities that are inside the absolute values equal to each other. Okay, and that generates one equation. And then the other equation is generated again by removing the absolute values and multiplying either the right side or the left side, one or the other, but not both, by a negative, and then solve those two equations. And that's what you would do. So I get x is equal to minus 7, or x is equal to 5/3. And you can easily check it by, if I put a minus 7 over here in the first, the left side, minus 7 times 2 is a negative 14, and 1 is a negative 13. Absolute value of that. If I put a negative 7 on the right side, negative 7 into minus 6 is a negative 13 inside the absolute values. But the absolute value of a negative 13 is 13 either way, so that one checks out. And if you plug in the 5/3 and try to check it again, you get the same thing. Okay. Now let's do the last one. Again, same type of problem. Has two absolute values, but they're isolated. So I'll apply the same procedure I just went over. So I said, again, if you have two absolute values in the equation and they're isolated, one on the left and one on the right, simply remove the absolute values and solve that equation. So this will become x plus 7 is equal to x minus 8. Okay, I would solve that equation. Okay. The next equation is generated by, again, removing the absolute values and multiplying one side, either the left or the right, by a negative. Doesn't matter which. In this case, I choose to multiply the left side. So the x plus 7 multiplied by a negative. And then the right side stays the way it is. X minus 8. Okay, then I solve these. Okay, so isolate the x. So this x and this x will cancel. So I get 7 is equal to a negative 8. Okay, that's a contradiction. So this has this equation right here has no solution. So that's the empty set. Now the other side, if I multiply through by a negative there, on the left side I get negative x minus 7 is equal to x minus 8. Okay, so let's add a negative x to both sides to cancel the x on the right side. So negative x will cancel, negative x over here is negative x and minus x is minus 2x. Adding 7 to both sides, that cancels over here. 7 and minus 8 is a minus 1. Okay, divide both sides here by a negative 2. Then and I get, in this case, one solution. X is equal to 1/2. And if you plug it in over here, put a 1/2 where the x is on this side, and combine this, I get 15/2. And that's the absolute value of that. On the right side, put a 1/2 there. I get a minus 15/2. And it's the absolute value of that. Well, the absolute value of a negative 15/2 is a positive 15/2, which is what I have on the left side also when I take the absolute value. So that checks. Okay, so my solution is x is equal to 1/2. Okay, this again is the video on solving equations that involve at least one absolute value. Okay, hope this was helpful, and we'll see you in the next video. Thanks for watching.